we're covering using rational equations to solve real-world problems, and specifically this time we're going to look at work problems, okay? Now before we do that, let's just do this warm-up question. So it says solve the system. Now the solution to any system is where the two functions will meet, right? So where f of x will equal g of x, all right? So I'm setting up the -4. Now sometimes I will accidentally forget that negative, so I'm just gonna bring the negative from the fraction just to the numerator. So we have -4 over x squared minus 10x plus 21. But this actually, I'm going to factor it right away. It factors into x minus 7 times x minus 3, right? -7 times -3 is 21. -7 plus -3 is -10x. And then that equals g of x. Now g of x is 1 over x minus 3 plus a second fraction, x over x minus 7. Now you might be able to see that in order to find what this equals, we will need to either get rid of all of the denominators or consolidate the right hand side to one equation, and then we could cross multiply. To one fraction, I should say, and then we could cross multiply. I like just canceling out the denominators, so I'm going to make all of the denominators the same. That way they will just cancel. So I'm going to multiply the top and the bottom by x minus 7. And I'm going to multiply the top and the bottom of this fraction by x minus 3. Okay, now that will make all of the denominators x plus x minus 7 times x minus 3. So if I multiply all of the fractions by x minus 7 times x minus 3, it would just cancel the denominators. So we end up with -4 equals x minus 7 plus x times x is x squared, x times -3 is -3x. Okay, now we have a quadratic, so I'm going to bring over the 4 to the right hand side so I can consolidate all of my terms. So I have 0 equals x squared, and then 1x minus 3x is -2x, and -4 plus -7 plus 4 is -3. Okay, now the coefficient is 1, multiplies to -3, adds to -2, would be positive 1 times -3, positive 1 plus -3. So this will factor into x plus 1 times x minus 3. Okay, so I have two potential solutions, x equals -1 and x equals 3. Now let's just go back and look at our extraneous solutions. Our extraneous solutions, looking at the denominators that we had a factor of x minus 7, which means that x could not be positive 7, and we have a factor of x minus 3, which means that x could not be 3 either. So these are our extraneous, our excluded values, which means that 3 is an extraneous solution. So that gets tossed out. So we only have one point of intersection, which is at x equals -1. Now, this is a point of intersection, so we need the y value as well, and you can either plug it into f or to g, it doesn't matter. I'm going to go ahead and plug it into f because it's one fraction instead of having two separate fractions. So f of -1 equals -4 over x, which is -1 squared, minus 10 times x, which is -1, plus 21. All right, so -1 squared would be 1. And -10 times -1 would be positive 10, and 21, of course, is 21. 1 plus 10 is 11, plus 21 is 32. So this is -4 over 32, which divide 4 on top and bottom would simplify to -1/8. So this is the y value of the ordered pair. So our final solution would be -1 is the x value, -1/8 is the y value. And this is the point of intersection where the two of these equations meet, the solution to the system. Okay, let's move on and let's take a look at some of the problems in this actual topic. So with these work problems, there are 3 work principles that we want to cover. Okay, the first work principle is if a job takes T amount of hours to complete, right? Then for each hour, 1 over t would represent the portion of the job that has been completed. So in other words, putting it very simply, let's try 2 hours, right? Let's say if I'm cleaning my room and it takes me 2 hours to completely clean my room. That's how long it takes me total. Well, at the for each hour, right, I would have completed 1/2 of the job, right? Every hour, each hour, 1/2 of the job gets completed. 1/2 in the first hour, 1/2 in the second hour. So I complete half of cleaning in the first hour, half of the cleaning in the second hour, makes up the total hour, the total 2 hours to complete the whole job. Let's say it takes me 4 hours to complete. Well, then that means that for each hour, only 1/4 of the job has been completed, okay? So it's just a very simple work principle. If it takes you T amount of hours to complete a whole job, then each hour, 1 over T would represent the value or the amount of the portion of the job that has been completed. Now, elaborating on that, let's look at work principle number 2, okay? If two entities, and let's just call the entities people, okay? If two people are working on the same job, okay, and it takes the first person A amount of hours to complete that job, and the second person B amount of hours to complete the job, if they were to do it alone, okay? So let's say if I'm doing cleaning my room alone and it takes me 2 hours, but my sister, it takes her 4 hours if she was doing the same exact job by ourselves, okay? Not together, by ourselves. It takes me, if I were to do it by myself, 4 hours. It takes my sister, or no, wait, the other way around. It takes me, if I were to do it alone, 2 hours, and my sister, 4 hours if she were to do it alone, right? Then the expression 1 over A plus 1 over B would represent the portion of the job that is completed each hour if we were to do it together, okay? So me doing it alone, it's 2 hours, right? So mine would be 1/2, and her doing it alone is 4 hours, so hers is 1/4. So the portion of the job, if we were doing it together, would be 1/2 plus 1/4, and that would represent the portion of the job that is completed every hour if we were doing it together, okay? So it makes sense because you're taking how much it would take me to do it alone, how much it would take my sister to do it alone, and if we were doing it together, you add them together, okay? And that would represent, again, how much is completed per hour. All right, so putting those two together, if you take work principle 1 and you take work principle 2 and you put those two together, you get work principle 3. And this is the one that we're gonna use. That's the most important one. So if you have those same two people and they're working on the same job, so they are working together, then the equation 1 over A plus 1 over B equals 1 over T can be used to find T, the time that it would take to complete the job. So this is very simple. You have, oh, that's interesting. All right, you have the, oh, I don't know how to fix that. Sorry guys, 1 second. Let's put that back where it's supposed to go. There we go. All right. So you have one person, right? How long it takes them to do it, A, and then you have B, the time that it takes the other person to do it. And if you add that up, that'll equal 1 over T. Now, T is, in this case, the time that it will take to complete the entire job. Okay? So let's do an example. Stacy can clean her apartment in 2 hours, okay? So Stacy, let's call her person A, she will take 2 hours to complete that job, okay? Then it takes her roommate 4 hours to clean the apartment, okay? So her roommate, let's call her person B, it takes her 4 hours to do that same job. Stacy and her roommate want to go to a movie. Okay, so they need to leave their apartment in exactly 1 hour and 45 minutes to arrive in time for the previews for the movie. Now, what they're saying is they're going to join forces, okay? They're going to work together and clean together. will they be able to clean their apartment in time to make it to the movie and see the previews, okay? So basically what we're looking for is we're gonna use that work principle 3, that's the one that we're always using, okay? 1 over A plus 1 over B equals 1 over T, okay? So we're looking for T. Is T less time or exactly the amount of time of 1 hour and 45 minutes, okay? Because if the time that it takes them to do it together is that time, then they've got, you know, they've left the apartment right on time. If they finish it earlier, then even better, right? If it's the less amount of time, even better, then they have some time to chill before having to go out to the movie. So let's go ahead and find it, okay? So Stacy, it takes her 2 hours. And her roommate, it takes her 4 hours. And we're solving for T. How much time does it take them to complete the job together? So let's change this to 2/4 so that we can combine. We need a common denominator in order to combine. So we have 2 plus 1, which is 3, and then the denominator of 4 stays the same. And now we have proportion equal to, 2 fractions equal to each other. We have a proportion, so we can cross multiply, right? 3 times T equals 4 times 1. And divide by 3 on both sides, so T equals 4/3. So it takes them 1 1/3 of an hour. Okay, now we have 1 hour and 45 minutes, so we need to figure out, we don't say, oh, it's 1/3 of an hour, you know, we want how many minutes exactly is that. So we have 1 full hour, and then what we're gonna do is we're gonna change the 1/3 of an hour and change that to minutes, okay? So how we change that is we just multiply by 60, right? There's 60 minutes in an hour. So I'm gonna change 1/3 by multiplying by 60. 1/3 times 60 is 20. So it takes 1 hour and 20 minutes if they work together. So to answer the question, will they make it in time to see the previews? Yes. Yes, they will, because it will take them this amount of time, 1 hour and 20 minutes. All right? Okay, so let's move on and do one more example together, and then you can try a couple on your own. Okay? So we have Jason and Hilger are required to paint over the graffiti on the wall. If Jason worked alone, it would take him 20 hours to repaint. Whoa, long time. Okay, so this is, we'll call Jason person A, okay? And working alone, it would take Hilger 15 hours to do the job alone. So we'll say Hilger's person B. How long will it take them to do the painting if they work together? Okay, so now we're just looking for what is the time, right? What is T? We're looking for T here, okay? So 1 over 20 plus 1 over 15 equals 1 over T. All right, so let's combine these two fractions together. We're gonna need a common denominator, okay? Now the GCF here, the least common multiple is 60. So I'm going to multiply this fraction by 3, and I'm going to multiply this fraction by 4. That way, the denominator here will be 60, and the denominator here is also 60. Okay, 4 times 1 is 4. Okay, now that the denominator is the same, we can group these two fractions. 3 plus 4 is 7, and the denominator of 60 stays the same. We have a proportion, so we can now cross multiply. 5 times T equals 60 times 1. So I don't know why I said 5. 7T equals 60 times 1, which is 60. So now we're going to go ahead and divide by 7 on both sides. So we end up with the time is 60 over 7 hours, right? Hours. Now, normally in real world, right, we don't say, oh, it's going to take me 60 over T hours. 60 divided by T hours. So you have to change that to how many hours, complete hours, and how many minutes. So what we're going to do is we're going to first round this to a decimal to do that, right? So 60 divided by 7, you can do it by hand or just use your calculator. 60 divided by 7 is 8 whole hours, okay? And then we get a remainder. 8 times 7 is 56, so we have a remainder of 4 over 7 hours. We're going to need to change those 4 over 7 hours to minutes. So all that we will do is we will multiply the hours by 60, and that will give us the minutes. So I could do 4 sevenths times 60, and it's 240 over 7, and we will round that to the nearest minute. So I will round that answer by clicking second and clicking enter. No. How is it that you change it to a decimal again? Oh, right here. The left and right arrows above enter, it changes it to a decimal. So it's about 34-ish minutes, okay? So 34 minutes. So it's going to take them 8 hours and 34 minutes working together. So a lot less time than if they were to do it alone. So definitely, you know, working together is always best. All right, so go ahead and pause this video now and try 2 and 1 on your own. All right, so looking at number 2, okay, this one says it takes 8 hours to fill a pool with a water hose. So notice that this isn't people, but it's the same, it's an entity, it's something that's happening, right? So with the water hose, it takes 8 hours, so we're gonna call this entity A. A drain pipe takes 11 hours to slowly drain the pool. Now, notice that one is filling and the other one is draining, okay? So it takes 11 hours to drain the pool. So this is negative, okay? When the owner decides to fill the pool, he accidentally left the drain pipe open. How long did it take to fill the pool? So he was trying to fill the pool this whole time, but he had the draining pipe working against him. So how long time total? Well, we would take 1/8, right, because it takes 8 hours, and we have to subtract 1/11 because this is actually a negative rate, right? Because you're draining the pool, so it's working against, which means that you're subtracting. And then that will equal 1 over t, which is the total time that it would take to fill the pool. Okay, so we need a common denominator, so I'm going to multiply this by 11 and multiply this fraction by 8, which would make the denominator for both 88. And then 11 minus 8 is 3. And again, this is a proportion, so you can cross multiply. 3 times t equals 88 times 1. So 3t equals 88, and then divide by 3 on both sides, you get 88 over 3. Okay, so we can't leave it like that, right? 88 over 3 hours. We can't leave it like that. So we can use our calculator again, do 88 divided by 3, and we get 29.3 repeating. So that means that the fraction is 1/3, the remaining fraction. Another way to do that is to do the 29 total whole, multiply it by 3, which is 87. So that means that we just have 1 remaining when we divide by 3. So the remainder is 1. So we have 29 total hours, and then we have 1 remaining. So we have 29 and 1/3 hour. Again, we take 1/3 hour and we want to change it to minutes by multiplying 60. 1/3 times 60 would be 20. So my final answer, it would take, the time that it would take to fill the pool is 29 hours and 20 minutes. A lot longer time. So leaving that drain pipe open costs a lot of money. All right, so let's move on to this problem. So this one says Carla can mow the lawn in 5 hours. So we'll call Carla entity A. And when Carla and Amanda, so here's Amanda, work together, together. So this is actually the total time, not how much it takes Amanda to work alone, but how much it takes for Carla and Amanda if they work together would be 2 hours. So that's actually T, and the missing piece that we're missing is how much it would take Amanda if she worked alone. So we're missing B in this case, okay? Now notice that it takes Carla 5 hours to do this job. And if they work together, it takes them only 2 hours. Okay, so it takes Amanda significantly less time than Carla doing this job alone. And the reason why I know that is because the time that it takes them if they were to do it together is less, right? So who takes less time to mow the lawn, Amanda or Carla? It would be Amanda. Because the time to do it together is less than half the time it takes Carla. Okay? So how long does it take Amanda to mow the lawn? Okay, then let's find that. 1/5 represents the time that it takes Carla per hour. And then 1 over B, that's what we're finding. How long does it take Amanda? And together, if they work together, that would equate to 1 over total time 2. So let's go ahead and solve for this. Let's combine these two fractions. So I'm going to multiply by 5 and multiply by B. So I have a 5b denominator and I have b plus 5 in the numerator. Okay, then I'm going to go ahead and cross multiply. 2 times b plus 5 equals 5b times 1. Now remember, there's multiple terms, so you have to multiply 2 to b and to 5. Okay, so 2 times b would be 2b, 2 times 5 would be 10. And then 5b times 1 is just 5b. Subtract 2b on both sides, we get 10 equals 3b, and then divide by 3, 10 over 3 equals b. Now 10 over 3, we have 3 total hours, right? 10 divided by 3 will be 3 whole number, and then 1/3 hour as a remaining fraction. 1/3 hour, we already did that work over here, is 20 minutes. So it takes Amanda, the time that it takes Amanda to do the lawn, B equals 3 hours and 20 minutes. I was about to write 1/3 hour and 20 minutes. All right. All right, so hopefully that is helpful, and I will see you guys in the next video. Bye.